Now it's time to turn to the structure of WebSphere Application Server. We'll start by looking at concepts common to all platforms. Then we'll quickly review what ATSWAS101 brings to the table. It begins with the application server. WebSphere Application Server is the overall product name. Application Server is but one type of server used by WAS. We start with your application, either a web application or an EJB application. Then we put that inside a Java virtual machine. Then we wrap all the open standard support code around your application. The open standards provide support for things such as servlets, JSPs, EJBs, JDBC, and other things that make the WAS JVM more than just a vanilla JVM. Under that, we put the platform-aware layer of code we spoke of earlier. This is what understands the platform on which it runs. Platform neutrality exists above the open standard line, with platform awareness below the line. Then we wrapper all that into the execution mechanism for the platform. For example, in Windows it would be a service. In AIX or Linux it would be a process. And on ZOS it's a started task. An application server is not limited to just one application. You're free to run many applications within a single application server. As you can imagine, there are reasons why you might not want to run all your applications in one server. The phrase single point of failure comes to mind. So WAS allows you to run multiple application servers if you wish, or combinations of the two. There are users of WAS that have very simple configurations, and there are users that have very sophisticated configurations. It's a powerful and powerfully flexible design. Let's now explore the other elements of the WebSphere Application Server topology. We just saw the application server, and we alluded to the fact that you may have more than one application server. In general, there are exceptions, but in general the application servers on a given platform image are grouped up into something called a node. In this case, a platform image might be a physical server box, or a logical partition, or even a virtual server. Each node maintains a file system with the configuration of the node's servers. The configuration files are primarily XML files. For the purposes of availability and scalability, you may define multiple nodes. We introduce another server type, which is the deployment manager. The deployment manager hosts the administrative console application, which is accessible with a web browser. The deployment manager maintains a configuration file system as well. The key here is that this contains the configuration for everything the deployment manager manages. This is called the master configuration. Configuration changes made through the administrative console are written to the master configuration. So far, so good. But how are those changes in the master configuration written out to the configuration file systems for each node? With the help of another server type called the node agent. The name tells the story. The node agent acts as an agent on behalf of the deployment manager, and it operates in each node. When configuration changes are made to the master configuration, the deployment manager signals out to each node agent that updates are available. The node agents then perform a series of get operations to pull the updated XML files down to each node. Each node agent then writes the changes to its local configuration file system. We then draw a dotted line around the whole thing and introduce another concept, that of the cell. The cell is simply the administrative domain for a given deployment manager. You may have multiple cells in your environment. That's very common. For example, we often see a development cell, a test cell, and a production cell existing within customer accounts, sometimes even more. When multiple cells exist, it implies multiple deployment managers. But for any single deployment manager, it knows about a set of nodes it manages. Those nodes then make up that deployment manager's cell. The administrative console is the primary interface for you to make configuration changes, deploy applications, and start and stop servers. It's not the only one. Other interfaces exist, such as a set of shell scripts or BAT files. There's also an administrative programming interface, so a scripting language such as Jython can be used to automate administration. But for now, we'll focus on the administrative console. It's a web application. As such, any standard browser may access it. We'll now take you through a brief video tour of the basics of the administrative console. Let's now talk about developing and deploying applications into WebSphere Application Server. As we mentioned, WAS applications are most commonly written with some development tools such as Eclipse or IBM's Rational Application Developer. The output of these tools is a series of files that make up an application. Those files are Java class files, web files such as HTML files, and picture files like GIF and JPEG, and a series of XML files called deployment descriptors. Deployment descriptors tell the story of the application. These files are read by the WAS Administrative Console when an application is deployed. That's how the Administrative Console understands what the application is and how to help you deploy it properly. The various application files are zipped up into a single packaging file called an EAR file. EAR stands for Enterprise Archive. To deploy an application into WAS, you use the Administrative Console. Again, this is a web application that runs inside the Deployment Manager. Recall also the idea of the Deployment Manager maintaining a master configuration for the whole cell. And recall further the idea of the node agent acting on behalf of the Deployment Manager to get configuration updates out to the nodes. The EAR file is loaded into the Administrative Console application, where the appropriate updates to the master configuration are made. The files are then copied out to the node and into the application server. This process is known as synchronization. Your application is then available in the targeted application server. It may then be started and used. Once an application has been deployed to an application server, it may then be accessed by users of that application. There are many different ways this may be done. We'll show a few of the more common methods here. We bring the application server with your application into the picture. The first and perhaps most easily understood access method is from a web browser. This implies the web browser accessing an HTTP port of the server. WAS app servers host HTTP ports as well as other ports. The next method we will illustrate is using web services. WebSphere Application Server is an excellent web services provider platform. Now in truth, web services is really a higher level protocol that rides on HTTP, so a web services client will use the HTTP port to get access to web services. There's another method of access to a web service which is over a queuing mechanism called JMS. We won't show that here just to keep things relatively uncluttered, but please do understand it is possible. Another type of application access is using what's called a message-driven bean, or MDB for short. This is a form of messaging that may use IBM WebSphere MQ or another queuing mechanism such as the built-in SI bus structure of WAS. The point here is that the MDB listens for a message to hit the defined queue. When it does, the MDB wakes up and pulls the message off the queue. Then it invokes the application. The final access method we'll illustrate here is that of RMI over IIOP. This is how Java programs often interoperate. We won't go into details of this here. Again, just be aware it is possible. The point here is that there are many ways in which to access applications deployed into WebSphere Application Server. This review was not exhaustive. We kept things relatively simple because this is an Essentials video unit. And the details of what we did show have been kept from you so the main concepts we're trying to deliver could be received and understood. Most applications have a need to access data to do what they're programmed to do. Here's where we start to show some of the open standard support provided by WAS. That's because data access is a key component of the WAS open standard support story. So we start with the application server and your application deployed there. Some access to the application is performed, which then drives a need for data. The data access support code is provided in the rich layer of open standards that blanket your application. The first we'll speak of is Java Database Connectivity, or JDBC for short. This is what allows you to access relational database products such as IBM DB2. The next is Java Connector Architecture, or JCA for short. This is what provides access to non-relational data stores such as CICS and IMS. The next is Java Messaging Service, or JMS for short. This is what provides access to messaging mechanisms such as IBM WebSphere MQ or the built-in messaging infrastructure of WAS called the SI bus. Finally, we'll mention web services because, as we said, WAS is an excellent web services provider platform as well as an excellent web services client platform. In the old days, data access routines were the responsibility of the developer, but no longer. Nowadays, those routines are part of the application server, and more specifically, they're provided as open standard interfaces. The design is very flexible. You can figure into WAS what you need and don't bother with connector methods you don't need. And many vendors support the open standards, not just IBM. Those other vendor drivers will work inside WAS. That's the purpose of open standards.